Well, hi, my little whippermathers. Do you like this holographic background? I thought you might, except for there's like a weird box that makes me look like I have a mustache. That's not the point. The point is, this week we are going to start adding and subtracting with mixed numbers. Some of you have a little experience with this. It can be a tough skill because we have to make a common denominator. So looking at this picture, I've got a third, and if I wanted to add a fourth, I would have two pieces, but they're not the same size. So I can't name them until I get the pieces the same. And I do that by finding a common denominator. I think most of you are pretty good at this. If not, I'll give you some help. Basically, you skip count by the bottom numbers until you find a common multiple. Ideally, the least common multiple, or the Lincoln cash mark. Now, watch me put my little doo-doo rule in so I can figure out exactly how many twelfths would be equal to a third and how many twelfths would be equal to a fourth. And I'm showing the work even though I know what 1 times 4 is because my eyeballs are checking my brain. So according to my math, 1/3 is equal to 4/12 and 1/4 is equal to 3/12. And then forgive my ugly picture, I paused it so you wouldn't have to watch me do it. There are my ugly twelfths, and as you can see, indeed, there's 4/12 on the left and 3/12 on the right. And now that the pieces are the same size, I can add them together. So if I had 4/12 and 3/12 together, I would have 7/12. Notice the denominator does not change because I did not change the size of the piece. Now, following, we're going to move into some crazier stuff like this one. What if I had 3 wholes and I wanted to subtract 1 2/7? I would need to make what I like to call a silly number. I take those 3 wholes and I break them to get me some sevenths. So look what I'm doing here. I have 2 wholes and 7 sevenths. 7 sevenths is the same as 1. 2 plus 1 is the same as 3. Now that I've made this silly number, I can subtract. 2 and 7 sevenths, take away 1 and 2/7 would leave me supposedly with 1 and 5/7. And I'm going to go ahead and cross it out on my model and see if that works. And indeed, I am left with 1 and 5/7. So now for the grand finale. This is as hard as it's going to get. You can do it. If I have 3 and a fourth and I wanted to subtract 2 and 7/10, the first thing I would need to do is make a common denominator. And I know that if I skip count by 4 and I skip count by 10, the least common multiple that I would get to would be 20. So watch as I add my little doo-doo rule to turn my tenths into 20ths and my fourths into 20ths. Once I do that, I am seeing something very disturbing, that the bottom number is bigger. I have 14 20ths on the bottom, 5 20ths on the top. So I need some more 20ths. This is a bit of a mess for kids that aren't really organized, and I know that from experience. So watch me turn this 3 into 2 and 20 20ths. Now I'm going to join my 5 20ths. I know it's getting crazy. I'm going to make this little arrow over. I call this the magical arrow because it will help you from making a silly mistake. And then here I go on the bottom, a magical arrow, 2 and 14 20ths. Listen, I'm just rewriting that so I can see what I'm doing. There's really no other reason, but it is going to change your life if I can convince you to do that. 2 take away 2 is nothing. 25 20ths take away 14 20ths leaves me with 11 20ths. Now, again, this is more of an organizational problem than it is anything else, and there's a lot of steps. Did you notice how I crossed out my 1/4 and my 7/10? It's because my brain literally cannot concentrate if there's all that stuff happening on the page. So some of you might have that same problem. And again, this is as hard as it's going to get this week. And after we finish this, we will have all fraction operations mastered, which is pretty exciting if you think about it. Okay. It'll be a fun week.